You're welcome to this session. My name is Joseph Ikhalia, and I work for Riela Cybersecurity. So Riela Cyber is a security operations center based in Balasala on the Isle of Man. And I work as the threat hunter. So my major role is to make sure the bad guys don't convert their security events to incidents in the organization. So I try to prevent incidents. And why am I talking about blockchain today? I have a very passionate history with the blockchain. The blockchain job brought me to the Isle of Man about 4+ years ago. I was lecturing blockchain and cybersecurity at Brunel University in 2018 and was headhunted to come to the Isle of Man to become IT security manager of the first fully licensed blockchain lottery in the world. So they were licensed by the Isle of Man Gambling Service Commission, the GSC. And it was a huge role. It was the most challenging role of my life till date, combining the knowledge of blockchain and cybersecurity. But before 2018, I was ghostwriting for a lot of, big publishing organizations. My contract would not allow me to mention their names, but you probably have heard about them. So we're writing about blockchain security trends from 2014, till 2018 when I became lecturer. Now, the blockchain has a very fascinating history. But before we start talking about these structure and the content for today, I'd like to take your minds back to 2008, where everything started. How many of you remember the global financial crisis of 2008? Millions of people lost jobs. The dear Lehman Brothers, they went extinct, from business. And it was around that time, at the fall of 2008, an unknown personality called Satoshi Nakamoto, it's a pseudonym. He published the first white paper on Bitcoin. And the paper was titled Bitcoin, a peer-to-peer electronic cash system. Some of you might have seen that paper. And he was arguing for the need for a decentralized peer-to-peer financial system where one computer can send digital currencies to another computer without a third party. Okay? So a trustless system so that we don't depend on the institutions, because we've trusted them for too long. So there was some form of philosophical, underpinnings to the creation of blockchain, Bitcoin particularly. And during the early days in 2008, in the Bitcoin forum, because the guy went ahead to create a website called bitcointalk.org. So it's a forum you discuss about the cryptocurrency trends and blockchain. During those early discussions, they predicted that other people would try to replicate this. They're going to create shitcoin, titcoin, and it was true. All these tokens were created, meme coin, mine coin, whatever the name is, it is. And that was the case till today. So after Bitcoin, we have the rest. Okay, I don't want to call the name. So in 2009, Satoshi mined the first Bitcoin, right? So the first Bitcoin was mined in March of 2009. And within the first block of the Bitcoin, we're going to explain what that means later on. He embedded a word in that block, and it's called Chancellor about to bail out, another failing institution. So that was the word there. It was a headline taken from the Times magazine. The Chancellor, maybe referring to the UK or America, I don't know, is ready to bail out another. So there's a lot of philosophical standpoints with regards to the creation of Bitcoin. But further down, 6 years later, around 2015, somebody thought that the Bitcoin blockchain is not enough. So we have to create a system of using this blockchain for other use cases, apart from just peer-to-peer financial transactions. They wanted to build a game on blockchain. They wanted to even host Netflix on blockchain. So people started inventing use cases. And that was Ethereum. You know, when Ethereum came, so okay, we're going to create decentralized applications. And from there, here we are. Okay? Now let's go through the architecture. It's very important we understand, because this architecture is layered and it kind of explains every blockchain that exists today, every top 100 blockchains. The first layer is the hardware and the infrastructure layer. So this is where you have your virtual machines, your computer. Remember, the blockchain is a software, it's code. It has to run on something, right? So we need hardware, we need resources. So this is the first layer of the blockchain. Your containers, your services. You know, if you do IT, you know about some containers like Kubernetes, Docker, and all of that. So the blockchain needs to run somewhere. You could put blockchain on Amazon Web Services. Yeah, you could deploy a node of the blockchain there. And till date, we have over 1 million Bitcoin nodes, active running nodes, geographically distributed. I think Ethereum is about 400,000 plus nodes. Okay, so that's the first layer, the hardware layer. We want that layer to be decentralized. We'll talk about that as we go along. We also want that layer to be distributed as well. So not only one node making all the decisions. Because that's why we have the data layer. Now in the data layer, this is where you have the records of transactions on the blockchain. This is where you have digital signatures, your public key, private keys, your transaction hashes, your timestamps. You know, this is how you prove that somebody who owns 1 Bitcoin is actually legitimate to send another person 1 Bitcoin. So this is the proof layer. This is the records layer. Sorry, not the proof layer, this is the records layer. Then the next step is the network layer. This is one of the heart of the blockchain architecture. So this layer allows users to send money and do transactions from one computer to the other. In the computing world, we call them nodes. As long as they are all participants on that blockchain network, be it Bitcoin, Ethereum, or the new one, Solana, you know, there's so many of them, Binance, blockchain, you know, they can send transactions. Then the most important layer, which is the innovation of Satoshi Nakamoto, was the consensus layer. Now this consensus layer is the innovation, because before that time, it was difficult to send digital currencies without preventing double spend. How are you going to prove that somebody has 1 Bitcoin, right? And how are you going to come to a consensus, an agreement? We had different ways of proving before. The proof of the Byzantine failover, okay? So, yeah, so that's it. That's the PB, proof of Byzantine. I'm gonna get the acronym again. So there was a previous consensus algorithm, right, that was used before, but it could not prove that Mr. A has X amount of Bitcoin without sending it to 2 people at the same time. And that is where the proof of work came. So Satoshi introduced the proof of work algorithm. What that means is that every computer on the network will do some computation, will make sure that they have done a lot of work, use resources in the system to solve a certain mathematical formula or equation. It's well beyond the scope of this presentation. I don't want to go into that. So you have to prove, because the network will broadcast, okay, now we need to solve this transaction, right? And everyone that joins that network will start computing. It's automatic. You don't have to do anything. Your system will do the computation itself. So that was the consensus. That was the way to prove that money can be moved from X amount of persons to other persons. We have the proof of stake, which a lot of blockchains use now, like Ethereum. Ethereum has migrated from proof of work to proof of stake. We have delegated proof of stake, DPoS, okay? We have proof of elapsed time, POET. There's so many consensus algorithms. But the father of them all is this PBFT that is keeping my mind. I think it's too old to remember. Now, when we leave that layer, this is where problem begins. So when people say the blockchain is not secure, this is what they mean. The application and presentation layer. Okay? And now you could also chalk in the execution layer, because for the blockchain to work, there's something we call smart contracts. Smart contracts are programmable, self-executing code, right? It's deterministic. Something has to happen before something else happens, okay? And it's just recursive like that. It's Turing complete, right? That means it will use your computing resources as much as possible. So we have that layer there. Now, this is where me and you come in, the humans. You know, let's assume Satoshi was a god, right? He created a very perfect blockchain. He deployed it on a hardware layer. He wrote the data layer code, the network layer code, the consensus. Now he allowed you to build wallets on it. So the first application that was built on the blockchain was wallets. Everybody needed a digital wallet to transfer money, right? Ethereum came and said you could build games. So the company that brought me to the island, they were building games on the blockchain, right? They had a very perfect gaming solutions, about 3 variants of the games. And this is where problems began. So every single issue that faces software architecture, software development, now becomes more critical, because all the applications built on this blockchain require some form of financial transaction. So it needs money. Before we have the internet of information and the internet of social, right? People need to interact and talk to each other. And all of a sudden, we're having the internet of money. So before I do anything on a software, you know, which they call Web3, I need to pay some amount of money, okay? So this is the layers. Now, what's the adoption rate? What's the growth? How is this thing well received, this concept called blockchain? In spite of the controversy, in spite of the rumors, the fears, you know, the doubts, uncertainties, a lot of bad headlines and press, the adoption is solid. I can tell you that. And it happens with almost new technologies. You know, when we had e-commerce, you know, everyone jumped on e-commerce. Now we have blockchain. Everyone is jumping on it. It's growing faster than the developers can even learn about it. So we have 170 million plus blockchain wallets worldwide. We have 18K plus developers working on open source projects. This is excluding private developers like the company that brought me to the island. They had about, I was managing about 45 developers in Southeast Asia. So this is excluding private work. We have 19 billion plus, you know, in this system. We have 195K times where people are actually looking for ideas and solutions around applications on the blockchain. So there is growth. But there is also the breach problem. We're going to come back again to the application layer because that's where the story gets exciting. This year alone, we've had about $2 billion stolen from blockchain applications that were deployed as bridges. So let's go back to different variants and flavors of blockchain. So we have Bitcoin, a blockchain. We have Ethereum, a blockchain. We have Solana, blockchain. These blockchains operate in silos. They can't talk to each other. So a lot of people have started creating new ideas to make sure that they are interoperable. It's just like having Mac and Windows. Imagine a world where a Mac computer can't talk to a Windows computer. We'll all be frustrated, right? So people are always developing protocols. So the first solution so far now is the bridge. So most of the problems happening today, the $2 billion loss so far, and the year is not even finished yet, is blockchain bridges. So when a Bitcoin, you want to transfer your Bitcoin without changing it to Ethereum, you want to use it in an Ethereum application or an ecosystem of Ethereum, you need a bridge. So the first bridge that we had an issue with this year was the wormhole token bridge. It was developed by Solana. Solana was trending, especially last year. It grew from 0 point something dollars to about $100 within a year for one token. So the wormhole bridge, I don't think the project continues anymore. $300 million exploited, the funds drained, project, bye-bye. How does the bridge work? Let's understand this bridge. So because the blockchain can't talk to each other, if I want to send my Bitcoin to Solana, I need to wrap it. The bridge, I'll send it to the bridge, is a smart contract, an application on the blockchain. So written by humans. So I need to send it to the Solana wormhole bridge. And they wrap it, they wrap it and stake it, and then they create an equivalent, like a synthetic Bitcoin. They call it wrapped Bitcoin, not the real one, equivalent, but it's mapped one-to-one. So they call it WBTC on Solana. So it uses the same protocol that the Solana blockchain understands. So with that, I could participate in any game, any DeFi lending and borrowing on the Solana ecosystem, make money and unwrap my Bitcoin and send it back to Bitcoin network. Okay? So what the hacker did here was he saw a vulnerability on the bridge. How do you find vulnerabilities in a decentralized, transparent, open network like this? How do you find vulnerabilities? You find it on the code base. And where is the code base? GitHub. So when you write a code for a smart contract, for a project like Solana, you have a GitHub page. You publish it there. So you commit. How many of you are familiar with development? Software development? Good. So you make a commit to GitHub. And it takes a while. How long does it take to accept the commit? Because in a decentralized format, it takes some time.
Well, I write very small code, so
yeah.
it commits fast.
Yeah, but in the blockchain world, if you upgrade a smart contract and you commit, they have to review it. They have to accept that commit. So there's a lot of manual process involved. You can't just write changes to the smart contract and commit it to GitHub and then expect the developers to automatically accept it. They will review it. So the hacker is always looking at this GitHub page. He's monitoring. Before now, we have proprietary systems. When you write your software, it's in a dev environment or a staging environment close to the organization. But now it's open for everyone. That's what we wanted, right? We wanted transparency. So the hackers have taken advantage of this weakness to study. And that's how they studied that, okay, somebody just committed to fixing a bug. That means it's not been accepted yet and distributed globally. So immediately, because he's a skilled hacker, started writing external smart contracts to make function calls to that vulnerable smart contract, which is the bridge, the wormhole bridge. And we'll discuss that later when I start talking about what are the solutions, because there's a lot of technicalities to this. I've spent years in this field, and I can tell you, I'm still catching up. Nobody's an expert here. Don't let anybody deceive you. You understand? So when we talk about vulnerabilities, there are about 33 vulnerabilities that most industries look at. But we'll just focus on 3 today. Okay? So now, why was this wormhole exploited? Pay attention now. So imagine you go to the bank. you have $100 in the bank, right? And there is a cashier, a teller, who is going to attend to you and pay you your $100. You want to withdraw $100. And you say, yes, give me $100. Instead of the teller to update your balance first, before giving you your money, they check your balance, you have it, and they give you your money. And before the teller updates your balance, you make another request for $100. And the teller gives you, check your balance, it's still 100, and gives you 100. And you make another request again. So the attacker was making a fallback function. And this thing happened far back in 2016 when we had the first major breach in the Ethereum ecosystem. We call it the DAO hack in 2016. $50 million was stolen. That resulted in the splitting of Ethereum into Ethereum mainnet and the Ethereum Classic. You know, so there was a division in the community. We cannot call back money into the system. The blockchain is supposed to be immutable. So even though we have a breach, we have to go ahead. That's the consequence. Some other people said no, you know, we cannot. The $50 million is too much. We could stop the hacker and collect back the funds. And that was how the network was splitted. So that happened in Solana. The same thing, as simple as that vulnerability. They call it re-entrancy attacks. So you can use a smart contract to call another smart contract, just like the Solana wormhole. It's a smart contract. The same thing, similar thing happened to Nomad Bridge. But Nomad was quite different, because this one is more recently, this is August. Nomad was writing a function and exploiting a value in the main contract function. So in Nomad smart contract, there was a function to say, when this executes, return 0, right? Or return true, whatever it is. But there was no function to check that return, that the validity of that return. So they just left it like that. When this executes, return true. You know? So there was no exception to check that condition. And that was what the hacker saw. And somebody again tried to fix that vulnerability, committed the changes to GitHub. So it's like some guys are just doing the right job every day, sitting down and looking at GitHub for changes and vulnerabilities to public blockchains. You know? And that was how $200 million was stolen. When this happened, the developers of Nomad, they found out the hacker's address. They sent a message to the hacker through the blockchain and said, we know you've exploited us. We will give you $10 million bounty. Can you return the 200 million? Of course, the hacker said no. You know, and then why were we trying to recover from August? This month, Binance announced they were breached. They were breached for 500 million actually. But our attackers were able to take 100 plus million, 110 million. Because the other coins that was converted, like USDT, is a stable coin, right? It's a cryptocurrency. They had a functionality in the blockchain to disable that transaction. And also, another controversy was that Binance was able to stop the blockchain. How can a blockchain be stopped? Remember, Bitcoin has 1 million computers, 1 million nodes validating transactions. And Ethereum has about 400,000 up until they changed their consensus. But Binance has just how many? 21 validators. So if you have 21 validators hosted in maybe a central data center like Manx Telecoms or Continent 8, is that really a blockchain? Maybe in theory it's a blockchain, but on the infrastructure level, if you go back to the infrastructure layer, there's a problem with the decentralization. And I made a tweet recently. I said, until a blockchain is decentralized, first with the governance, the people, And then the infrastructure, we want it in different, if you check Bitcoin map, you're going to see how many nodes and in what country. Texas has the most nodes, and then some parts in Kazakhstan, China, and all those countries. You know, you will see that it's evenly distributed. So if you take down Texas, Bitcoin continues. When China banned Bitcoin, Bitcoin continues. So there's no company, no CEO, no central authority in human form, right? But in other blockchains, it's not the same. So we want decentralization across all layers. And when we talk about another issue about regulation, most regulators at the moment don't really understand what to regulate. I rather they regulate the operations rather than the technology. Because you can't regulate a technology that's still evolving. You know, most of us don't really know what it is. Remember when electricity was developed, right? When we, the royal we, developed electricity, we thought it was a toy for the rich, right? Yeah, we thought nobody knew what to do with electricity until we started developing use cases. And that is the same thing with blockchain, right? Henry Ford said if you had asked people back in the day what they wanted, they would have said a faster horse. They wouldn't have said an electric car or a steam car, a faster horse. So we don't know what Bitcoin can do, but we know it has potential because there is no CEO, there is no company. Now, let's look at the last one. How are we doing for time? Is it up to 20 minutes now? I want 10 minutes questions because I think there'll be a lot of questions. So prepare your questions. I'm avoiding being too technical because there's a lot of technical elements to avoid. One of the most important part of this thing is this, the issue of decentralization and also the issue of social engineering, which I'll talk about in the last slide. And then we'll talk about the solutions. So because Solana is not well decentralized on the infrastructure layer, most of their servers is in Amazon. So if Amazon goes down, Solana has a problem. So we've been having outages. Solana has had about 4 DDoS attacks since they were created in 2018 or 19. About 4 DDoS. How do you take a blockchain down? It's like an insult to Satoshi Nakamoto. How do you take a blockchain down? Now, this is the last problem. Social engineering. And potentially it affects a lot of people. How many of you have crypto wallets here? Or you interact with DeFi applications? I do. I have multiple. How many of you have more than one wallet, more than one interaction? Good. You need to. Because right now, hackers are busy. If you go to Telegram, you go to Discord, you see them there. 99% of all operations around the application layer of the blockchain is fake. It's fraudulent. You know, recently I've dealt with about 3 cases. People, you know, help friends around, although it's not my core job, but I help people to investigate cases. Somebody brought to my attention a user who put a proposal on a decentralized system called Terra Luna. Terra Luna is a blockchain. They put a proposal there that replicated a legitimate proposal. So in a decentralized system, if you want changes to the blockchain functionality, you can write a proposal and the community votes on it, right? They use the tokens to vote. So somebody copies another transaction, another proposal, and pastes it there because you have money, you could propose anything you like, and he puts a malicious link. So I clicked on the link. The link is supposed to say, connect your wallet to vote on this transaction. I didn't have to connect my wallet. I'm already connected. But guess what the malicious user was looking for? My seed phrase. He said to vote, you need your seed phrase. And for those of you who are familiar, your seed phrase is essentially your private keys. And that is what a lot of people are doing now. So that is the one that is visible. There are codes you can write that is not visible to the user. You click on the link and it takes your private key. It hijacks your private key. It has happened several times. You need to check your wallet and see how many applications you are connected to and try to reverse engineer if they have the rights and permissions that you have given them, if they are using the actual rights and permissions. It's happened before. So a lot of users are clicking on these phishing links everywhere, from Telegram, from Discord, from WhatsApp. Yes, the WhatsApp groups sending malicious links. You get prompted either to put your private keys, or sometimes you don't even see the input field. You just connect, and you connect to a malicious application. And because this technology is fast evolving, there is no security mechanism yet to scan every single Web3 application. You know, I think it's high time somebody start thinking about it. How do we start developing those mechanisms? And then the phone is stolen. What are the security solutions? The first thing is, when developing those smart contracts, the application layer now, I don't think we need any more blockchains. We have enough blockchains. There are over 100 plus blockchains and thousands, hundreds of thousands of applications. Now, in developing those applications, we cannot start writing boilerplate codes, that's custom codes from scratch. Especially codes that does a lot of mathematical computations. It's irrelevant. There are trusted frameworks like OpenZeppelin. You know, if your developers are good, they can use OpenZeppelin, already tested, proven, you know, by experts, and you can use that to write your smart contracts. So that reduces the attack surface of your smart contract applications on the blockchain. Security audits is very important, but it's quite controversial as well, because some will argue when Nomad deployed, before the Nomad bridge deployed their smart contract, they audited the smart contract, right? It passed security test. But now on the blockchain, they were exploited. So you need more than security audits. You need monitoring, active monitoring of the blockchain. And a company does that very well called Cetic. Cetic has an infrastructure to monitor on-chain transactions. So you can easily spot, you know, crime and breaches. The use of multi-signature wallets, especially in organizations, you know, with large pool of funds. If you're making a charity donations, you don't want it to go to a single wallet. You don't want to pay to a single wallet. You need multi-signature wallets. It's extremely important because a lot of frauds around peer-to-peer escrows, malicious peer-to-peer escrows, where you, instead of sending money to an exchange and getting the equivalent, you don't want anybody to know your transactions, you send to an escrow account. That escrow account needs a multi-signature wallet. If not, one person goes away with the funds. And then you need to promote the security culture. You cannot overestimate or overstress this enough, the need for a security culture, because at the end of the day, what I really think is that while a lot of technologies will fizzle out, a lot of use cases of this blockchain will fizzle out, let's say 90%, there will still be a little bit left. There's a reason why people need anti-censorship implementation of blockchain. There's some reason why some people need transparency. There's a use case for decentralization. So when you start looking at all these important use cases, you know that this has a future. So right now, it's important to start getting awareness that is relevant for the industry to progress. So with this, I'm going to say thank you. And if you have any questions, I am happy to take them. Thank you very much.